Hey everyone, welcome to the Tech channel. Today we have another heart rate sensor. It's the MAX30102 pulse oximeter and heart rate sensor. I used one before, but it was like a $1 module and it was very difficult to use. You can check the video about it too if you want. But this one cost me actually like $10 and it's very good. It has 8 pins, but I soldered only 4 to use it with a I2C bus, and I'll be using it to measure heart rate and also other things like oxygen concentration in blood, and I'll be using it with my Oled screen and also a buzzer. There are video tutorials about how to use each one of them, and all these things will be used with my Arduino UNO board as usual. So let's wire our module and check some codes. So the wiring is very simple. I'm gonna use my breadboard, and here we have like 4 pins. We have ground. I'm using breadboard and some jump wires. So ground, I missed the point. Okay, ground is CL, is DA, and VCC. I'll be using 5 volt. That's it. So 5 volt from the Arduino, ground, and it's DA with A4 as usual, ECL with A5. So that's it for the wiring. I'm gonna plug my Arduino and check some codes. So right below you'll find link to the project article with libraries and all things, codes you will need, also the wiring. So first let's begin with an example from the library. So the library, as you can see, it's called MAX30102, but this one works with like 30102 and also some other models. Let's check first the heartbeat plotter. I'm sorry, didn't plug my Arduino. Okay, let's open the serial plotter. And put your finger. Wait a little bit until it gets like the values, and relax and stop talking. As you can see, my heartbeats are easy to spot, and with using the heartbeat library for this, it will be easier for the library to calculate, not like the one we used before. The heartbeats wasn't like they weren't so clear, but this one they are very clear as you just saw. So that's for the heartbeat plotter. Let's go check another code. The heart rate. Open serial monitor, and as you can see it detects if you have no finger placed. So let's put our finger. So as you can see, it measures like the raw values, which are the IR from the sensor directly, Then there is an algorithm, and a lot of calculations are done to get the BPM and the average BPM. So in the project with the OLED, I'm gonna use the average BPM. It's very simple and it's very stable rather than the BPM directly. And as you can see, if you get calm and your BPM doesn't change too much, the average BPM pretty much equals the BPM. Let's check another code. The SpO2 is the oxygen concentration in the blood. The previous sensor couldn't do this task. So the oxygen concentration in blood should be above 95%. So here you place your finger and then you send something from the serial, write whatever you want. First it gets a sample of the correct reading, that's why you should place your finger. Then it will start calculating. So that's the reading of the SpO2. And I wanted actually to integrate this code with my OLED too, but let me show you a problem we have. It's over here. As you can see, low memory available. It may occur some problems. Well, I wanted to use it with my OLED. The OLED doesn't light up at all. Just there isn't enough space for all the variables. I tried to remove some things from the codes, change the variables and make the code shorter, but it didn't work. So maybe for an Arduino Mega or something more powerful it will work nice. And don't forget, this module has also a temperature sensor built in. "25, 24, it's the ambient temperature. You can place your finger, but it won't give you the right temperature, maybe after a long time. But overall it gives you the ambient temperature, and it's actually pretty pretty stable and accurate. But unfortunately it doesn't give you the temperature of your body, as this it measures parameters of your body, but the temperature sensor gives you only the ambient temperature. But it's still a nice feature to have here. So now let's add our OLED and also a buzzer for the project. I'm gonna add now my OLED screen, and as you know it's also a square C. So I will take a VCC first from 3.3 volt. The ground. From the ground over here. And for ST and SCL, I will take them from sensor. Okay, my OLED, I hope it's clear. I will check the camera later. And I'm gonna add my buzzer. Ground from the ground. VCC from 5 volt. And then the input signal from pin number 3. I have a lot of wires. I'm gonna plug the Arduino and upload the code. So that's the code functioning as you just saw. It tells you first to place your finger over the sensor, and we saw in the previous codes it detects if your finger is placed or no. So here, as you can see, if your finger is not placed, it makes the BPM average to 0. Then you place your finger and you should be calm and wait a little bit until it starts calculating. And as you can see, there's a little picture of a heart over here, and every time there's a beat it starts moving. Like, it's not moving, it's actually another picture. I'll show you how to do it. And then the buzzer makes a noise every time there's like a beat, a heartbeat is detected. So now we're gonna check the code and see how these things are done. So this is the code I made for the project with the OLED and the buzzer, and it's very simple. It's just a modified version of the previous code that is the BPM. So here first I have the libraries for the OLED, then for the sensor there are two libraries actually. There is like one dedicated for the heart rate, and if you check like the other code for the SpO, there is a dedicated library for the SpO. Like complex things are done behind, you won't care about them, and complex things are done behind, so to make your project easy and simple. So here we declare our sensor, and here we have like the rate size is 4, like how many rates do we want to take to make the average. So it takes like 4 and makes the average of them. And we have like the rate spot and the beats, so we measure like the time between the beats, and those are the variables we want like in the end, the beats per minute and the beats after average. So here we have declaration for the Oled screen, it's usual, and here are the two pictures of the little hearts. I have one here and other one here. I'll show you how to make this. So you should have like so here you should have like pictures for the, do you want to make them in the Oled screen. So I have this one, it's very little because those are like the size of it is just 24 pixel by 21 pixel, and this one is 32 by 32, and I made them very little to fit in the OLED screen, in the little OLED screen. So you make this with whatever like software you have, Photoshop or anything, but just don't forget, like in the end, I'm gonna open it with Paint. In the end you should like save it as this format, as bitmap monochrome, or monochrome bitmap in English, and try to make like pictures in just two colors, because my OLED is just one color, black and blue. So here the surrounding will be like in black, and here it will change to blue. So once you have like your pictures you want to fit in the Oled screen, just go to this software. I will leave the link right below. You find it in the article. Open it, LCD Assistant, and then it tells you to load the image. I'm gonna charge like this one, and here you can try whatever orientation you want. Just try one and fit it in the code and display it on the Oled screen. If it doesn't work, go maybe to the horizontal, and here just remember the width and the height, 24, 21, and then save output. We'll give it a name. Okay, now it's saved. So then go to the file you just made and open it using NotBlock maybe. So here you have like the file. You can introduce this number to your like a code as you just saw here. It's exactly this one. You just copy this and place it in a like whatever name you want. So here I named them logo 2, and there's like a logo 3. Give them whatever name you want. So here this is how I had like these two pictures. Let's continue our code. So here in this setup we have just like the beginning of the like Oled screen, and then our heart rate sensor. Just like start them, and here in the setups they can like for some application you need another setups like this SpO2. So for the SpO2 it needs like this special setup, but the one before we use just like the default setups. So here are the raw value that's given by the sensor, and we play like if they are bigger than like 7000, it's considered that finger is placed here, otherwise the finger is not placed. So here let's begin with this. So if it doesn't detect like any finger, it tells you like to place your finger constantly. It's written on the screen, and the bit average is set to 0. And also for the buzzer there is no like no sound coming from the buzzer. So, and if you place your finger, actually it gets bigger than 7000, or actually more bigger, it's 100,000 maybe. And here we draw like our first picture, which is like the mini picture of the heart. So here don't forget this function. We'll draw bitmap, and here from where you want to start drawing your bitmap, and here the name of the bitmap you want to draw, and also here the width and the height of the image you just made. And here also the color. You saw me use a lot of white. There are some Oled screen with white and other one with blue, but you can use white if you have blue, no problem. And here we set text size, text color, and cursor from where we want to write. And here write BPM and beat average. As I said, the beat average is more stable, and as you saw it takes like 4 rates to make the average, which is good. It's not like the average of all the calculations, just 4. And here we check if there's a beat. So if a beat is detected, the display will be clear, and like draw the bitmaps as like from 0 0. Now it's we see like the other picture which is more bigger, then it gets the effect of like a heart beating. And here the width and the height of the image same like this, and white. And then we kept this, it's the same thing from here to here, like it's the same thing, just the image that changed. And then for the buzzer it tones like at this frequency, which is like they give the effect of a heartbeat. So here I may be like a little bit wrong with this delay, but just to give the effect of like the image if I don't make this delay here, you won't see the image, and also the buzzer will not tone like at all, or you will not hear anything. So it may like affect a little bit calculation, but it's not very clear. So here we take like the duration between 2 beats, and then we calculate them just to get do some little calculation to get the beats per minute. And then here for the averaging, we take, like as I said, 4 rates, and then calculate the average of them. And that's it for this module. That's all the things like I've added. For the previous things, those are just like examples from the library, and this one is just modified example from the library to fit in my OLED and buzzer. So that's it for this module. If you have any problem, you can write it in a comment or contact me. Don't forget to like and subscribe, and see you next time.